Okay, so let's take a look at that last set of homework problems that are due as part of solution concentration. Now, I hesitate to tell you this, but on your test, you're not going to see any of these dilution problems, but you still have to turn them in for homework. I might go ahead and make an extra credit problem this semester related to these dilution problems. So let's take a look. So in all of these, I've gone ahead and I have a picture of a stock on the left and a picture of the diluted on the right. And these are ugly looking volumetric flasks, so just bear with me. But in this first case, notice we have, for our stock, we have 1.2 molar, and we given the volume of 22 milliliters. Now this whole entire contents is going to be diluted up to 500 milliliters. And you see my question mark down there is what is the molarity of the diluted solution? So we can kind of think of it stepwise. The thing we know most about is the stock solution. So we can use that volume of 122 milliliters and that molarity of 1.2 moles per liter to get to moles. And that's exactly what I would do. That's actually going to be the moles of sucrose that are going to be diluted up to that new dilution, that new volume of 500. So if we get those moles, then all we got to do then is once they're transferred and diluted up, we take those moles and divide it by 500 milliliters. Okay, so that will give our molarity of our diluted solution. So that's how to work that one. Oh yeah, and down here I remind you that remember molarity is in moles per liter, not in moles per milliliter. So if you're doing your keeping up with your units, you'll catch that. So you have to tack on one more term here, and that would be what, Becky? We want milliliters to cancel, be 1,000 milliliters over 1 liter. So the next one, again, here's my picture of my stock solution. Okay, and I'm going to transfer 25 milliliters of 12 molar HCl over to another flask. And what I want to know with regard to that diluted solution is, it looks like I'm given molarity, and I want to know what volume I need to dilute it up to. Looks like if I didn't, I should go like this, question mark volume. Okay, so that's what we're after. So again, just if I look at my pictures, the thing I know most about is the stock solution. Now that's not always the case, but from that 25 milliliters I transfer and that molarity I'm given of 12 moles per liter, notice I can get to moles that were transferred, and you can kind of see it in green there. So I'm going to get moles that were transferred. Now in this case, now I have moles and I have molarity. I have moles that were transferred in, become my diluted solution. I have those moles and I have molarity, so I need to get to volume, so it looks like this. So I'm going to use that term from 1. That's going to be my first term, be moles over 1. And then my second term, you see 1 liter over 0.500 moles. That is molarity, okay? And so then, of course, I might want to get my volume in milliliters, and so I tacked on that last term. So that's how we would do that one. They're all a little bit different, good, bad, or otherwise. I think bad. So here we have, again, stock and diluted. And again, looks like we're gonna transfer all of our stock and make it diluted. Okay. Wait, no, I guess not. How much of a, sorry. So in this case, we have the molarity of stock, and we don't know how much to transfer to make this diluted solution. Now, notice this, it threw me off for a minute. Now we know more about the diluted solution than we do the stock. Now we know the volume of the diluted and the molarity of the diluted. So actually that's where I'm going to start with. So my first step is to use that 850 milliliters and that molarity of 0.250 moles per liter to get to moles of HNO3 that are swimming around in that my diluted solution. Okay, so that will give me moles. And then once I have moles, that actually came from my stock via my transfer volume. So then I can go ahead and use moles and molarity of the stock to get to the volume of the stock. So it looks like this. I just kind of piggyback on my moles will be my first term over 1. And then I'm going to use the molarity of my stock. And then to get it into volume of milliliters, I go ahead and tack on that last term. So that's how you do that one. Like I said, they're all a little bit different. And this last one is even different yet. So this last one, we have a dilution going on, and notice we're going to dilute up all of our 125 milliliters of our 8.5 molar NaCl stock. We're going to dilute it up to a volume of 2.5 liters. And we've done problems like this earlier in this set, how we can get the molarity of that diluted solution. Actually, that's what I'm going to go for. I'm going to have you go for. But ultimately, the problem says I want to take a certain amount of my diluted solution such that I get 10.8 grams of NaCl. Okay? So I'm going to tell you I would start out very similar to, I think it was the first problem in this set, where we're going to use the volume and molarity of the stock to get to moles. And then we're going to take those moles and divide it by the volume, 2.5 liters, to get the molarity of the diluted solution. This is very similar to 81. This is the way I would do it. So now I have molarity of my diluted solution. So as a side calculation, and some of you may already kind of be thinking about this, since we want mass, we're going to have to actually knock out the molar mass of the solute, the molar mass of the NaCl. So calculate that aside. Now we're ready to go for the grand enchilada, or I don't know how you want to say that. So now we can actually, I would start as my first term, the mass, the target mass, that 10.8 grams of NaCl over 1. That's what I would do. And then I would go ahead and convert that to moles using the molar mass. And then I would go ahead and use the molarity of our diluted solution. Now that I have moles, I can use molarity to get to liters of solution. And that actually could probably stop right there, but I think I would take it on to milliliters like we've been doing. Okay, so I hope that makes sense. Again, you're not going to see a dilution problem. Heck, I'll go ahead and make a dilution problem extra credit on your exam. I haven't done very many of those this semester. So, but yeah, let me know if you have any questions.